So we'll go over a couple graphs with you. The book problems, they tend to be on the easier side for the most part. There's only a few problems that really move the amplitude, phase shift, and period. So I would use that Desmos generator that I put on here to make up as many problems as you need to really feel comfortable graphing. And really what I found year to year is labeling the x-axis. That tends to be the toughest part of all of this. So really focus on just making sure you get the x-axis labeled correctly. Make sure your increments are correct, and you've got the key spots on each graph that you really need. For sine and cosine, it's really where they cross the x-axis and the highest point and the lowest point. That's really all the key points you need to have. So let's jump in and do 49. First up, we'll find the amplitude. Hopefully pretty straightforward. There's an understood 1 in front of sine, so amplitude is 1. Remember, amplitude is how far from the middle you go, how far from the median, so that's always positive. All right, symbol for frequency is omega. I don't know if I've used that yet, so just in case, you'll see me do that a lot, and that's what it means. Frequency here is also 1. There's an understood 1 in front of the x. Period goes with the frequency. It's 2 pi divided by the frequency, so in this case, just 2 pi divided by 1. And your phase shift. Now this is the most involving part up to this point. Take whatever's in the parentheses here, and we're going to compare this to sine of 0. Sine of 0 is where the sine function typically starts. That's our initial point at the origin. If we figure out where this stuff would equal 0, that tells us where that point at the origin gets shifted around. That's your phase shift. So take this, whatever's in parentheses, set it equal to 0, and pi over 4 is going to be your phase shift. Now, while I'm at it, now this is really all you need for day 1. So if you're just checking for day 1, you can stop here. If you're ready to check this for day 2 on the graph, then keep going. So after I get the phase shift, I like to immediately do this. Take what's in parentheses and set it equal to 2 pi. I found a lot of students kind of get tripped up on what I'm doing here. What I'm really doing, again, I set this stuff equal to 0 to see where that point at the origin got shifted. I know that this sine function typically will end when I put in 2 pi right here. I don't mean it ceases to exist, I just mean that's completing one full cycle. If you start 0, when you get to 2 pi, you've completed a whole cycle around that wave and you're getting ready to start over again. So whatever you choose to set this stuff equal to, it basically tells you where you would be in the normal wave and now where it's going to get shifted. So what new x value leads to the original point. So what I'm getting at is when I put in sine of 0 for the original sine function, the point is 0, 0. But for this function, I'll need to put in pi over 4 to get, that's where that 0, 0 got shifted on the x-axis. Okay? So one complete cycle is done when I set this stuff equal to 2 pi. If I want to see where it's going to be at the top of the wave, that usually happens at pi over 2. So I can set this stuff equal to pi over 2. When you get into some of the other functions, you're going to want to set what's in here equal to other things besides 0 and 2 pi. That's why I'm talking about it now. So if it's not completely clear, hopefully it'll clear up by the next section. So I want to figure out what x is in this situation. I'm going to add pi over 4 to both sides. Now to do that, I really need this to be out of 4, so let's make it 2 over 1, but let's turn it into fourths, so that would be 8 fourths. I guess I'll scratch the 1 out. So that would add 0. This would now be 9 pi over 4. So one cycle will begin at pi over 4 and end at 9 pi over 4. The period is still 2 pi, so that should check out. That's a quick check you can always do. Is the distance from the beginning to the end of the wave the same as the period? If it's not, something's wrong. One of those two things is wrong. You need to check both. But they're matching up, we're good. Now, most all of these problems are going to ask you to do 2 full cycles. So this is the point where most people have trouble, or at least this is the most difficult part I've found over the years for most students. So we want to start at pi over 4. We want to end at 9 pi over 4. And the way I'm drawing this out, and notice I'm drawing this. I'm not giving you a preloaded graph because it really, for the most part, it's easier to just draw these out put the increments where you need them to be. So I'm going to do one full wave first, then I'll do a second wave. Again, on tests and quizzes, I'm going to ask you to do 2 full cycles, but get the first one done first till you're comfortable with how to do it, and then get the second one done. So pi over 4 to 9 pi over 4. Okay, let's go back up to our period. It's 2 pi radians. So there's a lot of ways to approach this. So I'll hit some of them, but you might come up with something you like better. It's whatever works best for you, honestly. So pi over 4 to 9 pi over 4. I like to think about, all right, well, what's halfway in between? Because when you think about a sine wave, you start here, you go up, back down, down, and back up. So halfway in between, you're back at 0. A quarter of the way, you're at the top. Maybe I should do it in quarters. All right, so start at the beginning, quarter of the way through the wave, you're at the top. Halfway through the wave, you're back to 0. 3/4 of the way through, you're -1. And at the end, you're back at 0. So if you divide this up into 4 equal parts, that tends to be the easiest way to go. And I like to kind of divide it in half first, then divide each one of those in half. That's my process. Whatever works for you is going to be best. Well, these are out of fourths, so that's really convenient. If they're not in the same fraction, same denominator, I would make them the same denominator, make it easier to think about how to divide this up. You can think midpoints. You can add these and divide by 2. Midpoint's just an average, really. Sometimes it's pretty easy just to think about what's in the middle. If this is, take the pi's out. It's 1/4 and 9/4. All right, what's halfway between 1 and 9? That's 5. So 5 pi over 4 will be right in the middle. Another thing you can do, you can take your period and divide it by 4. So that would be pi over 2. And every pi over 2 radians, you're going to get another increment, another tick mark. It's whatever works for you, okay? So I like this method where you just keep cutting things in half. 1 pi and 5 pi with 3 pi's in the middle, so 3 pi over 4. Halfway between 5 and 9, that's 7, so 7 pi over 4. If you feel pretty good about the first cycle, then you can go ahead and keep counting. So 11 pi over 4, 13 pi over 4, 15 pi over 4, and we should be ending at 17 pi over 4. Okay, so that's 4 more segments, so that's enough for an entire wave. Amplitude, make sure you get that correct. Our amplitude was 1. So really I'm just going to make a -1 line right there. You can add more ticks, that's fine. Just make sure you've got it clearly labeled with the highest and lowest is going to be here. And that should really do it. So I'm starting at pi over 4. I'm ending at 9 pi over 4. Sine starts at 0, ends at 0, so that's one complete wave. And then in between it just, we know it goes up to 1, back to 0, down to -1. And that's really all I'm looking for. So once you start over, back to 1, back to 0, down to -1, back to 0, and then just play connect the dots. Really, you should put some arrows on the ends of this thing, make sure that actually touches the dot. But it does keep going, so put arrows on the ends so you can see that it definitely keeps going. 55 is more like what to expect on a test or a quiz because I've got things going on everywhere. I've got on Desmos an A, B, and C value. This is an amplitude, this is a frequency, this is, together those make up your phase shift. So a lot of pieces happening. This is more like what you're going to be assessed on. I want to see that you can handle all these parts and know what they do. So let's jump in with amplitude first, all right? Amplitude is 2/3. No matter what, it's always positive. If this was a -2/3 out front, amplitude is positive. It's displacement. It's how far above and below the median you go on the wave. All right? If you think about ocean waves, sea level, it's how high the swell gets, how much it drops, okay? It's a distance, so it's always positive. Next is our frequency. I don't know if this was on the homework. I can't remember, so I'm putting this and period. If it wasn't on there, then don't worry about it. But this is x over 2, so if you think about what that would be times just plain x, it'd be 1/2 times x. Your period would be 2 pi divided by your frequency. So let me just put that up there one more time. 2 pi divided by your frequency, that's your period. So 2 pi divided by 1/2 would be really 2 times 2 pi, so 4 pi. And then your phase shift. So for phase shift, that's really the only thing that requires work. Pi over 2 minus pi over 4 All right, find out where it equals 0. So x over 2 would equal pi over 4. Multiply by 2 to get rid of that. And we're going to get pi over 2. So our phase shift is pi over 2. If you're just doing day 1, you can stop here. That's really all I'm asking you about on day 1. If you're ready to do the graph, then let's continue on. So cosine, now usually we start cosine at 0, but the y value is at 1. So just keep that in mind when we go to graph. Typically, one full cycle of cosine ends when we get back to 2 pi. So I'm going to take this stuff and I'm going to set it equal to 2 pi. Now, if you really wanted to, you could set this equal to pi over 2, and then you know that's where the y value should be 0. You can set it equal to pi and see where the y value should be -1. I mean, that's stuff you can do, but most people don't really choose to do that. I don't think you need to. So let's solve this. Add pi over 4 to both sides. All right. I really want the 2 pi to be out of fourths, so let's make that 8 fourths. And this will be added to 0 now. All right, so now we're up to 9 pi over 4. We want to multiply by 2 on both sides to get rid of that. And we're going to end up now at, I just want to make that clear that I'm multiplying. We're going to end up at 9 pi over 2. So that's where we begin and end a full cycle of cosine, which or wave, if you want to say it that way. So for your graph, I'm going to start with pi over 2, end at 9 pi over 2. So there's pi over 2. We'll put 9 pi over 2 about halfway down the line, because I want enough for 2 full cycles. Now, amplitude. It's up at 2/3. So here's what I'll do. I'll put 1, and I'll put some little tick marks. And however you want to do that's fine, as long as you indicate to me that, hey, I know it's 2/3 here, it's as high as it goes, and -2/3 is as low as it goes. If you want to label those, that's fine. Just make it clear to me, understand how that works. Pi over 2 to 9 pi over 2, that's kind of convenient. This one ended up with the same, a lot of the same numbers as the last one. So halfway between 1 and 9 would be 5. So 5 pi over 2, 3 pi over 2, 7 pi over 2. Again, you can take midpoints and then take midpoints of those, which would be adding these two together divided by 2, and these two together divided by 2. You can take your frequency, or sorry, your period divided by 4, so it's in 4 sections. Now in that case, it would be pi. So you're adding pi to each one of these, pi radians. So whatever works for you. Since most of these are the same as what we just did, except I think a different denominator, I'm not going to do the second cycle because I think you can handle taking care of that just for the sake of the example and time. So we are graphing cosine. Remember, cosine begins at 0, 1. So instead of 0, 1, I'm shifted over to pi over 2. Instead of going up to 1, I'm only going up to 2/3. So I go up to right there. Next thing cosine does is it comes down to 0, then to -1, so in this case -2/3, back to 0, and then back up to the peak, which is at 2/3 again, and then you just start the process over. So if you divide it up into 4 equal sections, it's always where it starts, quarter mark, halfway mark, and so on. It just makes it really easy to know where it peaks out, where it crosses the axis. It's really all you need to have. So connect those dots, and we should be good. And then I did put this on Desmos, so if you want to check, just to show you kind of how that process would go. That's the last one, sorry. 2/3 was the amplitude, 1/2 was the frequency, -pi over 4 is the phase shift. Be really careful on that part. The way I have this set up is it's just plus whatever this number is, so if that's negative, make sure you make it negative in the Desmos. And as soon as you put a pi in here, it starts counting the x-axis in pi, so that makes it really convenient to check these. Hopefully it'll show up on the camera, but it is pi over 2, 0. It is 3 pi over 2, 2/3, 5 pi over 2, 0, and so on. So you can check all those key points and make sure they match up with what you have.